Oh, you're back. So glad that you decided to continue on with another exciting installment of simplifying radical expressions. So the question was raised, so I just multiplied times what I see in the denominator. Right, Kelly?
Mm-hmm.
So let's go. Is that what you want to do? What is 8 missing?
Square root 8.
Square root of 8. So top and bottom, right? Just like the other examples. What does this give me? Almost. There you go. That is 10 square roots of 8 over
8.
8. Do y'all agree?
Yep.
No, we need to reduce like we did in the last problem, right? How does it reduce? Common factor of 2, so you end up with 5 square roots of 8 over 4. So we just box that, right? Look at 8.
Let's do that.
What is it about 8? Isn't 8 made up of factors 4 times 2?
Yep, maybe.
So what's the square root of 4? Because I've got a perfect square inside. He's going to give me a 2 on the outside. So we're going to multiply those and get what? 10 square roots of, not 8, but 2 over 4. Oh, look. I get to reduce this even more, right?
What?
I know. What? And this reduces to 5 square roots of 2 over 2.
Okay, we're done now, right?
So you're going to show us how to do
Well, you know,
how to
if
do
I'm
that?
putting a box around it in pen, you know we're done.
I didn't look up until I did.
It's Dylan, it's okay. But let me show you the other way of working this problem.
Because Javi.
No problem. Dylan is awesome.
See, I'm so
But his sister Karis is even awesomer.
Yeah. She's awesome.
Oh, snap.
Kind of hurts a little bit.
You're always playing second fiddle to the older sister, right?
I guess. No.
Let's look at 10 over the square root of 8 again.
He's giving me quite a funny look.
I didn't say anything about faces. I just said the voices and the references. Now, 8. What is 8 made up of?
2.
It's made up of 3 factors of 2, right?
Yeah.
Now, in that funny little thing that I was doing before, actually I really should have these in blue. I said I needed to have perfect squares, right? Well, I've got 2 factors of 2 to fill up 1 perfect square for that guy, right? And then I have what?
Another 2.
Another 2. So what's really missing so I can have all of my squares complete? Just 1 2 is missing, right?
Yep.
So if I do that and I just multiply times the square root of 2,
Is this another way of working?
this is a little bit shorter way of working it because in the last time we did this, we put in a lot more than we needed to put in.
Why wouldn't you just do like 4 and 4 like you did up there? 4 and 2, I mean. And break down the 4.
Which would still be 2 times 2. So it's 3 factors of 2 here, right?
Okay.
You could do that. You could say 4 times 2 and then break down the 4 as well. No problem. So what happens when I multiply these radicals together? What do I get?
Square root of 16.
I get the square root of 16, which equals what?
4.
So that means in my problem here, my numerator is 10 square roots of 2 over 4, and that reduces to 5 square roots of 2 over 2. So 8 contained a perfect square. You just need to finish the factors that were not a square.
I feel like I'm more likely to mess up on that.
Hey, if you want to do it like up here, you can, but there's a lot more work. There's more simplifying that has to be done.
How'd you get 4 from the square root of 2?
I did not get 4 from the square root of 2. 8 times 2 is 16. And the square root of 16 is 4.
What?
8 times 2 is 16.
Yeah, I get that. I'm just confused now. I don't know what you did, but I'm confused.
I broke down the 8 to see all of his factors. I'm
Mhm.
still leaving that as 8 inside the radicand, or inside the radical. So when I look at the factors of 2, I know that, well, those guys are a perfect square together.
Mhm.
This guy is not, so he was missing the 2. There's the connection right there.
Okay.
Okay. So now that I have all of these factors of 2 right here, that gives me 16, and the square root of 16 is 4.
So I guess, I don't know. Okay.
Okay. I mean, really, you could have done this a third way if you wanted to. Because you could have simplified the square root of 8 first. Because we know that 8 is 4 times 2, right? What's the square root of 4? So 8, the square root of 8 is 2 square roots of 2, right? And if I look at it this way, whether I simplify now or simplify later, what's the factor that's missing here? I'm just missing a square root of 2 here, right? Now what's going to happen when I look at just these square root factors? What does that give me? Square root of 4, which equals 2. So in my numerator I have 10 square roots of 2 over what? 2 times 2 is 4, and that still reduces to give you 5 square roots of 2 over 2.
Nice.
All 3 ways will get you the same answer as long as you pay attention to what you're doing and what's missing for these guys. Now, it's useful for you to see what's missing so that when you have a problem like this, it won't throw you off.
We can't see the problem.
Fine. My goodness.
Oh, thank you so much.
De nada. 2 over the cube root of 9. Think about what 9 is made up of. It's made up of 3 times 3, right?
Mm-hmm.
So if I were to make my little pie like I was doing before, I'm dealing with the cube root, so that means I have to have 3 of the same factor. Do y'all agree? What does the 9 give you? It gives me 2 factors of 3, right? So what's missing to finish the cube? Another factor of 3, right? Do y'all agree with that? So in this case, unlike the other ones, I'm dealing with the cube root. So if I put a square root here, that doesn't make any sense for me. I've got to match the radicals here. I've got to match the indices. So what's going to be inside the cube root? 3? Do y'all agree?
Mm-hmm.
Now look at these radicals here. What's the cube root of 9 times the cube root of 3? Cube root of 27, and what's the cube root of 27? I was going to say 3. Right?
Yeah.
So now in the numerator, I just have 2 cube roots of 3 over 3. I had to put in what was missing to complete that power, to complete that cube. And what was missing was just this factor right here, was this factor of 3. Because you knew that 9 was already made up of 3 times 3, right? How many of the same factor did I need? I needed 3. So now that I've got that, I simplify, and I'm done. Questions about that? And if you understand what I did there by making these little diagrams here and what I made up here, that's going to help you for this next problem. If I have 5 over the 4th root of 2 x to the 3rd y squared, to rationalize this problem, to rationalize this expression so I don't have a radical in the denominator, I have to make sure that everybody inside the radical is a perfect what power? A perfect fourth power. Now when we do this, it may help you to draw your little diagrams to see what's missing and what you have. Now when I draw these diagrams, I'm just going to draw little boxes here, like this. How many factors of 2 do I have? I've got one factor of 2, right? Now why did I draw boxes that had 4 spots in them? It was a fourth root, so it needed to have things to the fourth power, right? All right. Let's look at
Wait, where'd you get the 2? I'm sorry, that was.
The 2 in front of it.
this 2 right here. I've got one factor of that 2.
I got lost. Sorry.
Now I'm going to look at the x's. How many factors of x do I have? I've got 1, 2, 3 factors of x, right? And then when I look at my factors for y, what do I have?
2.
I've got y times y. Do y'all agree? Now, just like we've been doing before, I'm going to write in those missing factors. Now, in order for me to do that, I have to use the fourth root. Do y'all agree? So, how many factors of 2 am I missing?
3.
I'm missing 1, 2, 3. So I'm going to write that here as 2 to the third. What's 2 to the third, though? What is 8, right? That's okay, folks. 2 times 2 times 2 is pretty tough. Now look at, so if this is 2 times 2 to the third, we said was 8, right? So what's 2 times 8? 2 times 8 is 16, and if you look at your power sheet, what's the fourth root of 16? It's 2, right? Because 16 is made up of how many 2's? 4. Now, how many factors of x am I missing? I'm missing one factor of x. I'm going to put that in both the denominator and numerator. How many factors of y am I missing? So I'm missing y squared here. Do you agree with that? So look what happens here. In my numerator, I simply get 5 times the fourth root of 8 x y squared over, and I'm going to show you this next step, and there's a lot of different ways you can write this. Inside the fourth root, how many factors of 2 did I have when I multiplied these guys together? You had 4 factors of 2. How many factors of x do you have?
4.
And how many factors of y do you have? You have 4. In order for this to be a perfect fourth power inside the fourth root, this index must go into all these exponents evenly. Does it?
So the 2 doesn't multiply to make 4, right? Like 2 times
If I multiplied 2 to the fourth, I would get 16.
2. No, I mean like inside, like you said it was 2x to the third, blah, blah, blah. You don't multiply 2 to get 4. You leave it at 2.
You mean here to here?
Yeah.
Notice when you did x to the third times x, the base of x is still the same, right? That even applies to when the base is a constant. If you have the same base, 2 and 2 is the same, or excuse me, 2 and 2 is the same base, you add their exponents, which is 1 and 3 to get 4. Right? So
So the denominator is 2x1.
your denominator, right. The fourth root of 2 to the fourth is 2, because look, the exponent of 4 divided by 4 is 1. 4 divided by 4 is 1, so that's x to the first and y to the first. Right? Now in the numerator, you just pretty much have to carry this over. There's nothing else you can do. If 5 could reduce with that denominator, you would. But this guy can't.